The V-belt drive has been around since the early 1900s and is the most widely used drive in industry. Over the years, it has proven to be very reliable, relatively inexpensive, and easy to set up and operate. But if the V-drive is carelessly installed and maintained, these advantages can disappear quickly. Hello, I'm Dave Brown for Teletrain. Because of the V-belt drive's solid reputation, people tend to take it for granted. Proper installation and maintenance are often ignored. Today we're going to cover the right way to install, maintain, and troubleshoot the V-belt drive. As we'll see, belt tension, sheave condition, and drive alignment are all important in getting the most out of a V-drive. If these three items are neglected, you can expect shortened belt life, wasted power, and extra downtime. We have removed a drive from the shop and brought it to an area where we can safely demonstrate its operating principles. Do not allow loose clothing, hands, or feet to stray near a drive that is operating or that could start without warning. Many people have been pulled into machinery. Okay, let's take a look at how a V-belt works and why careful maintenance is important. The V-belt transfers power from the driver, usually an electric motor, to the driven equipment. Both the driver and driven equipment have pulleys or sheaves mounted on their shafts. Sheaves may have a fixed bore, which must be matched to the individual shaft, or they may be used with separate bushings which allow the sheave to be adapted to different shaft diameters. Let's take a closer look and see how a belt and sheave work together to transfer power. A V-belt gets its gripping power by wedging against the sides of the sheave when the belt is forced down into the sheave groove. The belt is forced deeper into the groove by increasing belt tension. This is done by increasing the drive's center distance, which usually means moving the driver and driven equipment further apart. Sometimes an idler is used to adjust the tension in a drive. By using the idler pulley to apply force to the belts, the effect is the same as moving the driver and driven equipment further apart. Both changing the center distance and moving the idler allow you to increase or decrease belt tension. When increased tension is applied to the belt, it will wedge deeper into the groove and push harder against the sides of the sheave. The harder the belt pushes against the sheave, the more gripping power there is and the less tendency there will be for the belt to slip when transferring power. If the belt does slip, the wasted power is turned into heat, which can break down the V-belt construction material and cause early belt failure. Belt slippage is by far the most common cause of belt failure and wasted power. But the condition of the sheaves and their alignment can also affect belt wear. If the sheave has burrs or rough spots, the belt will be gouged and will have a reduced service life. If the drive is misaligned, the load will not be distributed evenly across the belt. As a result, some parts of the belt will wear faster than others, and the belt will fail sooner than it should. Okay, it is important to understand that a V-belt's gripping power is directly related to belt tension. If we want to transfer a certain amount of power without the belt slipping, we need to provide the right amount of belt tension. Suppose that this drive needs a total of 210 pounds of tension to transmit power without belt slippage. Since there are 3 belts, this means that each belt needs to supply 70 pounds of tension. When one of the belts is worn and can no longer withstand 70 pounds of tension, it fails. And when it does, the 2 remaining belts will still be supplying only 70 pounds of tension each. And since 140 pounds of total tension is not enough to turn the driven unit, the belts will begin to slip. Now, in this situation, there are 3 ways to come up with the necessary 210 pounds of total tension. First, if you're in a hurry and also want to get every bit of service from the belts, you could simply retension the 2 remaining belts. But they must now each supply 105 pounds of tension to make up for the missing belt. And chances are they weren't designed to take the extra load. Plan on some future downtime because they will probably fail soon. Secondly, you might be tempted to simply add a new belt to the drive. But when the new unstretched belt is tensioned, the old belts, which have stretched, will be hardly tight at all and will transmit very little power. The new belt will have to bear most of the load. If you tension the new belt normally, the drive will have little more than 70 pounds of total tension, and the new belt will certainly slip. If you try to eliminate the slippage by over-tensioning, the new belt will have to provide the entire 210 pounds of tension. In either case, the new belt will fail quickly, and you'll be back to where you started. The third possibility, changing all the belts, often turns out to be the most practical. If the belts are replaced as a set, they should all wear at about the same rate, and each will be pulling its share of the load. In the long run, you can reduce the number of times a drive needs to be shut down for belt replacement if the entire set is replaced. Now, as we replace the set of belts on this drive, we're going to pay close attention to the sheaves and their alignment. Then we will concentrate on tensioning the belts correctly. Some of the procedures we will show may be difficult to perform on some of your drives, but if you are able to adapt them to your situation, your efforts will pay off in increased belt life and reduced downtime. The first step, before doing anything else, is to shut off the drive and electrically lock it out. Then make sure to remove the old belts correctly. Never pry the belts off with a screwdriver, which might slip and injure you. Instead, shorten the distance between the sheaves until the belts can be slipped off easily by hand. As we've said, it's important that the sheaves be in good shape. Check to see if there are burrs or anything else on the sheave groove which might damage the belt. Using a gauge, which is often available from your vendor, check sheave wear. To make sure the groove is not dished out and allowing the belt to slip, follow the manufacturer's recommendations for how much wear is acceptable and when the sheave must be replaced. Make absolutely sure that if you do replace the sheave, the new sheave is identical to the old one. Not all sheaves are alike. This is particularly important with high-speed sheaves. High-speed sheaves are specially constructed and balanced. If a standard sheave is used to replace a high-speed sheave, it may shatter at high speed and rocket pieces of metal out in all directions. As you can guess from this photograph, it happens fast and it can be deadly. Just because the sheave is new, don't assume it's in perfect shape. Check the inside of the sheave hub and the groove for defects. Also, if you're using a bushing, take a look at its tapered surface to make sure it's smooth and won't damage your sheaves. With the key in place, slide the sheave and bushing along the shaft and place the unit where it looks like it will be aligned properly with the remaining sheave. If both sheaves were removed, use these two general guidelines for sheave placement. First of all, the sheaves must clear the rest of the machinery and the belt guard. Secondly, the sheave should be placed as close to the bearing as possible in order to reduce overhung load. Overhung load refers to the lever effect on the bearing if a sheave is placed far out on the shaft. If you have any doubts about placement, it's usually safest to place the sheaves along the shaft exactly where the old ones were. Then snug up the mounting screws. Now, before we go on to aligning the drive, let's see how to make sure you'll be putting on the right belts. When selecting replacement belts, there are three important things to avoid. First, don't mix belts of different design on the same drive. Secondly, don't change one belt design for another without checking with your supervisor. And finally, don't mix different manufacturers' belts on the same drive, even if they appear to be the same size and of the same design. It is safest to replace worn or failed belts with new belts which have the same identification markings. Let's take a moment to look at some of the differences in design and construction that you might run into and why it's important to install identical replacements. There are three common belt designs: the conventional or classical belt, the narrow belt, and the raw edge belt. The conventional belt is still the most common and is sized A through E. The narrow belt has a thicker profile than the conventional belt and has a V in its number. Narrow belts are sized 3, 5, and 8. Narrow and conventional belts are not interchangeable. In fact, the narrow belt requires a different sheave for its use. Both conventional and narrow belts have an outer jacket made of rubberized cotton or man-made fibers. This jacket helps protect the belt from abrasion and from occasional contact with oil. Raw edge belts, on the other hand, do not have this protective covering all the way around the belt. Instead, they often have a greater load capacity and bend more easily around small sheaves. These belts are sized to fit either conventional or narrow belt sheaves and have an X in their ID number. Because raw edge belts do not have a protective cover, they may be more easily affected by their operating environment. A final and very important reason not to mix belt designs or belts from different manufacturers is that they may require different amounts of tension. The result may be that when placed on the same drive, some belts may be over-tensioned while others remain under-tensioned. Now, when it comes to aligning the drive, if possible, perform the alignment before torquing down the cap screws and installing the belts. First of all, this will allow you to make small alignment adjustments to a sheave instead of moving the driver and risking a major realignment. And second, the alignment process is usually easier if you don't have belts pulling against the sheave while you're trying to move it. But in some situations, the driver must be moved back to its operating position before the alignment will be close enough to check, so you'll have to put the belts on first. In this case, torque the sheave cap screws to the manufacturer's specifications. Then put the new belts on while the center distance is shorter. In fact, you may find that even though you have already shortened the center distance to remove the old belts, you may have to further adjust the drive in order to slip the new unstretched belts over the sheaves by hand. It is absolutely essential that new belts not be forced onto a drive by using a screwdriver or any other means. If the belts are forced on, there's a good chance the tension cord in the belt will be damaged in the process. Tension cords carry the load and provide the belt's strength. If the cord is damaged or stretched when installing the belt quickly becomes useless. Belt turnover is often caused by broken or damaged tension cords. Now, one of the advantages of the V-Drive is that it does not require exacting alignment techniques, which is a good thing, because aligning a V-Drive perfectly can be very tricky. But it's worth the time to come as close as you can. The better the alignment, the longer your belts, sheaves, and bearings will last. These are the ways a V-Drive can be out of alignment. Usually, misalignment will be a combination of them. To correct for this kind, you'd move the motor forward or backward. For this kind, you'd shim the front or back. And for this, you'd rotate the motor. To check the alignment, place a straight edge across the faces of the sheaves as near their centers as you can. The straight edge should touch the two outermost spots on each of the two sheaves. If it doesn't, move the motor in the proper directions to get the straight edge touching the sheaves properly. Then repeat the procedure on the other side of the hub. For example, if you took your first reading to the right of center, now do it again to the left. If the straight edge does not touch the sheaves properly now, you will have to try another adjustment. Keep repeating this procedure, checking each side of the center and adjusting the motor until the straight edge touches correctly on both sides of the hub. Finally, rotate the sheaves a half revolution. The straight edge should still line up properly. If not, you probably have a wobbly sheave or even a bent shaft. When you're satisfied the drive is aligned, tighten down the motor hold-down bolts. Then, torque the sheave cap screws to the manufacturer's specifications if you have not done so already. Now we are ready to tackle the single most important V-Drive maintenance procedure, applying the correct belt tension. If you don't get this right, much of your effort up till now will be wasted. From what has been said so far, you might think that the tighter the belt, the better. After all, the greater the tension, the greater the gripping power. But unfortunately, belt tension also affects the bearings found in the driver and driven equipment. Increasing the belt tension not only increases gripping power, it also increases bearing strain. The farther the shafts are forced apart to increase belt tension, the more the belts are going to pull on the shafts and against the bearings. The correct belt tension strikes a balance. The belt needs a certain amount of tension in order to transfer power without slipping, but not too much or the bearings won't last. The trick is to apply the right amount of tension to the belt, not too much and not too little. You have already seen a couple of the more popular methods of coming up with the right belt tension. There are several other methods. Some of them work better than others, but they all depend on years of experience. The problem is, even experienced people may have trouble adjusting their methods to the greater tensions that must be applied to today's belts, particularly the narrow and raw edge belts. Many belt experts have different opinions on the second best way to come up with the right belt tension, but they do agree that the best way is called the force deflection method. The force deflection method makes use of formulas which relate the actual belt tension required to transmit a load to the amount of force it takes to deflect a belt after it has been installed and tensioned. Fortunately, most manufacturers have done the math for you. You will need a tape measure, a spring scale, and the belt manufacturer's instructions. Carefully follow the manufacturer's instructions and make sure that they actually apply to your situation. Before using the force deflection method and the manufacturer's charts, you must be certain that the correct type and correct number of belts are being used on your drive to avoid overloading the bearings. If for any reason you cannot use the force deflection method, contact the manufacturer directly for the proper way to tension your drive. When you can use the force deflection method, the procedure will usually follow this general pattern. First of all, apply a preliminary amount of tension. A good rule of thumb is to apply enough tension so that the belts have a live, springy feel when struck with a hand or pushed down with a thumb. Then measure the belt span length, the distance on the belt between the 2 points where the belt first contacts each sheave. You're measuring to the nearest inch, so don't worry about finding the exact contact points. Now we'll use the span length to find out how much we're going to deflect the belt to get the right tension. Using a spring scale, apply enough force in the center of one belt to deflect the belt 1/64 of an inch for every inch of belt span. If the belt span came out to be 32 inches long, then move the belt 32/64 or 1/2 inch with the spring scale. Read the amount of force it takes to do that on the scale. Then compare this reading with those suggested by the manufacturer. As you can see, the chart will often give a range within which your reading should fall. By changing the distance between the sheaves, adjust the tension to fall between the values given by the manufacturer. Depending on the drive setup, you may need to adjust a motor mount screw. But if you have to loosen motor base bolts to apply tension to the belts, the job is going to be tougher because retensioning may affect the alignment. Regardless of which mounting method you are using, once the proper tension has been set, make a final alignment check. When you're satisfied with the alignment and belt tension, remember to replace the belt guard before starting the drive. Now you've inspected the sheaves, the drive has been aligned, and the belts have been properly tensioned. Much of the job is done, but it isn't finished. Once seated and under a load, the belts will now stretch and the tension will be reduced. If the V-drive is to do its job without wasting power and wasting belts, proper tension must not only be applied, it must also be maintained. Belts will stretch the most in the first few hours of operation. Listen for belt squeal. If they are squealing, the belts are slipping because they're too loose. Stop the drive, lock it out, and tighten the belts. Do not use belt dressing to quiet them. Belt dressing can break down the belt material without solving the problem. Slipping belts need to be tightened, not dressed. After 24 hours, check the tension and retension the drive if necessary. Then check the tension again after 72 hours of operation. It's a good idea to make an occasional check even after that. The belt may still have up to 3% more stretch after the 72-hour break-in period. Now, before we're through, let's see how we might troubleshoot a drive that's going through a lot of belts very quickly. If you're having a lot of trouble with belt turnover, there are two probable causes. First of all, someone may have changed the drive requirements without adding on extra belts to carry the extra load. Sudden shock loads can cause belt turnover when there are not enough belts to provide enough tension in the drive. If you suspect this situation, contact your supervisor or belt manufacturer and double-check the drive design. But the fact is, improper maintenance is often responsible for belt problems. We've already seen that prying a belt on can cause belt turnover. So check the belts to see if there's any evidence of this, like gouges on the jacket. And if so, find out who is causing the problem. The condition of a belt's jacket can tell you a lot about what the belt has gone through. If the belt is dry, cracked, and brittle, the belt has gotten too hot. Heat can break down belt material. If a belt has been slipping, it will appear glazed along its sides. Make sure that the correct tension is being maintained in the drive. If you are unable to maintain the correct tension, have the drive design checked. If the jacket appears gummy, then the belt is in contact with oil, or someone is using belt dressing on the belt. Both of these materials can eat away at the belt's protective jacket. Finally, if the jacket is chewed up or shows uneven wear along its surface, there are two likely causes. Material can be falling into the drive and gouging the belts, or the sheaves may be in bad condition or out of alignment. The V-belt drive has been a workhorse of industry for over a half a century, and a good deal of time and effort have been spent to improve it. But it is up to you to apply your time and skill to V-belt maintenance, or the improvements are wasted. Drive alignment and sheave condition are important to prolong belt life. Use the right belts on a drive. Apply and maintain the correct belt tension. Belt tension can affect V-drive performance more than anything else. I'm Dave Brown for Teletrain.